Hi, welcome to OPOLab. This is the class OSSD Grade 10 NPM 2D, Chapter 5, Applied Quadratic Models, Section 5.1, Stretching and Reflection Quadratic Relations. So in this section, we're going to talk about the translation for the quadratic relations. Okay, the first one is called the reflection. Okay, there is an quadratic relation called y equal to x squared, and we have already solved the graph. So now we need to explain what's the y equal to negative x squared. So we already know that if where a greater than 0 it is upward, and a smaller than 0 it is be downward. So for this relation, we can know that the graph is going to be upward. Okay. So as I can see for this original function we have the always y equal to x squared, but this relation is b times the negative 1. So we can know that it equals the reflection to the x-axis. It means it be upward to the x-axis. So you can know that where a smaller than 0, it is called be reflection at the x-axis. So these are some examples we can explore here. The first one, we just to check out the a if they greater than 0 or smaller than 0. Yeah, first one is the a equal to negative 3. It is smaller than 0, so it's reflect to the x-axis. The second one, y is reflected from, so we need to express it. So it equal to 2x minus x squared times 2 negative x. And you can notice that there is negative 1 x squared, so it's reflect to the x-axis. But the third one is already write it down for negative x-axis, so it's reflect to the x-axis. Reflect. Okay, the final one is called do. We need to write this form to make sure about there are no negative at the beginning number. X plus 3. Okay, we already solved it. There is negative x squared, so we can know that it is also reflect. Okay. Now let's see the second one called the vertical stretch. Also, it's already given another relations to talk about the difference of the original one. So first we can find the table for find x can be negative 1, negative 2, 1, 2. Okay, so for the relation, we can plug x here to the function. We can note that when negative 2, y is 4, well, y is 8, and negative y is 2, 0 is 0, 2 is 2, 8 is 8. So we can, for the original one, this is y2, this is 1. For y1 is 4, y0, y4. So we can draw the graph to the y2. Okay. This one is 0 and this one is y. Okay, this one can be mixed with the 4. Okay. The y2, y equal to 2. This one is 1 and where this point is 4. Where now we can draw the graph y2, where x equal to 1, the y can be 2. For x equal to 2, it can be 8. So we can know the graph is like that way. You can see the y2 is be stretched to the y1. So yeah, this section we can call that the vertical stretch. It means the y values can increase the faster and quickly. So how to know that? So if we a equal to, we need to add the absolute value to that way. I equal to 2 greater to 0, we can know that it is the vertical stretch. Understand? Okay, the next one is called the vertical calculation. Okay, we already gave it. It's the same one. We need to draw the graph first. Okay, for the y2, and this is for the y1. The y1 is 4, 1, 0, y, 4. Okay, let's find the y2. The y2 it will be equal to y equal to, and 2 gonna be half. So the graph will be look like that. It will be bigger, and it will be wider than x1, y1. So we can know that it's called the vertical calculation. That means when a greater than 0, smaller than 1, so it's called that. vertical calculation. Let's do some example. For the first one is called y equal to negative 3x2. So first we need to check out the factor a. A is equal to 3 is greater than 1. So we can know that it's vertical stretch. And now let's take it because it have the negative 3 smaller than 0, so it's called the reflection. Reflected axis. The second one, the absolute a equal to 2 over 3 is greater than 0 and smaller than 1, so we can know that is the vertical calculation. The third one is called the 2 over 6 equal to 1 over 3 is greater than 0 and smaller than 1, so it's the also vertical calculation. And also it have the negative 1, so it's also the reflection. Reflect to the x-axis. That's the end of this section.